Good morning to one and all present here. I welcome all the participants to this third day short-term training program on nanotechnology and functional materials phase 2. Now we are going to start this third day first session. Once again, thank you for joining with us. Now let me introduce our eminent resource person, Dr. Veeraraghavan Sharma, Professor, Department of Chemistry, GITAM Institute of Science, Visakhapatnam campus. He is having more than 10 years of postdoctoral experience in various universities in abroad like Purdue University, USA, University of Chicago, USA, University of Freiburg, Germany. He has published more than 43 research articles in international publications. He has presented nearly 10 research articles in seminars and conferences. He has successfully completed research-funded projects by DST SERP NPDM. He has published an excellent book on medical chemistry in drug delivery through IGNO publication. He was granted more than 11 patents and still submitted more patents for the benefit of society. More than 5 research scholars have completed their doctoral degree, and currently 8 research scholars are pursuing their doctoral degree under his guidance. He has achieved more than 12 awards and recognition from both international and national level. He is being board of member more than 6 reputed journals as a reviewer and editor. He gave numerous guest lectures, training in this area of research specialization, and he is taking a vital role in various policy-making decisions at institutional level. We are honored with your presence, sir. Now I am requesting our resource person to continue with the session. Requesting, sir.
Yes, sir. Yeah. Just let me switch over. Yeah. Yes, sir. Very good morning to one and all. Thank you very much, sir, Dr. Manivannan, sir, for your kind introduction. I consider myself as very fortunate to be here with you this morning. Before I go further, I would like to thank Dr. Chandrasekhar Reddy Garu, HOD, Mechanical Engineering, the Venkateswara College of Engineering, for inviting me to give a talk during this faculty development program. I consider myself as very fortunate to be with you and to share some of my thoughts and insights into this fast emerging field of nanoscience and nanotechnology and functional materials. I just let me open my presentation. Yeah, I just asked you whether you could see the slide. I hope the first slide. Nanotech. The title of today's talk is Nanotechnology Applications, Challenges and Opportunities. Here, nanotechnology, I said, it includes nanoscience. Okay, so I will be talking about a few of the very selected areas of nanotechnology for the benefit of this learned audience. I hope you can see the presentation.
Yes, sir. Yes, sir. Yes.
Okay. Thank you very much. Thank you. Yeah. This is the first slide. My email ID is given here. Address is given. Title of today's talk. Before I go further, just I would like to recall the great sayings of Swami Vivekananda. Believing others is easy, but believing in yourself, that is the real challenge. One has a great potential, but recognize it. That's a a big challenge. Another legendary Abdul Kalam's quote: "If you want to shine like the sun, first burn like a sun." What it means is that unless you put effort, you cannot achieve anything. There is no shortcut for success. That's what I understand. Now let's move on to the topics for today. A brief outline of the topics that I would be covering during this session are given here. What is nanotechnology and nanomaterial? Of course, all the participants here, you're all learned colleagues, but for the benefit of everyone else, I would like to just recall some of the very common fundamental points about some of the concepts before we get into the subject really. So the first one is, what is nanotechnology and what is a nanomaterial? Then what is nanochemistry? What way it is relevant to this technology? Nanomaterials in various applications. What are various possible applications of nanomaterials in our daily life? Then nanomaterials particularly focused on solar cell, that is solar cell technology, conversion of solar light into most useful energy, that is electrical energy in today's context. Nanomaterial catalyzed chemical reactions. This is one of the most important areas that I am more interested in. Okay. This should be the way in the future a chemical reaction should be designed. Nanomaterials in medicine, drug discovery, drug delivery. It's a need of the hour today. Okay. We'll be just laying two things about it. Then, last but not the least, molecular machines and molecular switches. A new concept which has just been emerging over the last few years, okay, which is going to play a significant role in the technological aspects. Could it be electronics industry, or could it be the pharmaceutical industry, or the other industry? So this is an area which is very, very important for us to understand in depth. That's why I have chosen only a few of the areas, and what I am going to do is put forward in front of you some of the latest works that are going on in these areas, assuming that it will be of benefit to all of us. So, it's a very simple question. Okay, there's nanomaterials or materials in which the particle size is in the order of 1 to 100 nanometers or 10 power minus nanometers. So such particles are called as nanoparticles, and the materials possessing these nanoparticles could be termed as nanomaterials. Nanomaterials, it's not a new term. It has been known centuries, since centuries. In our own country, many centuries ago, people were using nanomaterials in their daily life. Therefore, nanomaterials occur naturally also, and they can be created in the laboratory or in an industry. Okay, by doing appropriate, design through a process which we call engineering to perform specialized function. These materials may have different physical and chemical properties. Okay, and nanocosmetics is a branch of nanoscience, deals with chemical applications of nanomaterials in nanotechnology. Okay. So that is what I would like to focus on as well. Now let us come to the types of nanomaterials. There are different varieties of nanomaterials possible. For example, the first thing when you say for a scientist or a faculty or a professor, those working in metal or in industrial R&D, the moment we say nanomaterials, the first thing that comes into mind is metal and metal oxide. and their derivatives. But one should expand their vision or horizon to many other sets of substances. Organic polymers, for example, when their size reaches the nano size, okay, so they can also be termed as nano materials. And they are being very well explored in today's context in different areas. Could it be electronics or in the delivery or page? We'll be coming to that part as well. Sensors with applications in electronics, biological applications, nanomaterials, are silicone. Different types of nanomaterials also belong to the molecular machines, switches. Nanometal oxides such as zinc oxide, magnesium oxide, iron oxide, they all come under nanometal oxides, which could be used as catalysts in several chemical processes. And let us go first to the applications before we go into the individual parts. Applications of nanomaterials. It spans across industries, right from, on the one hand, healthcare, to cosmetics, to environmental, to air purification, removal of air pollution, and so on and so forth. When you come to the medical and biological applications of nanomaterials, the thing that comes to our mind is drugs and how to deliver those drugs into the human system, and how to trap the toxic substances, how to immobilize certain unwanted enzymes which cause unwanted health disorders, DNA transfection. All these aspects are present when we talk of application of nanomaterials in medical and biological field. When you come to the solar cell technology, organic solar cells are the latest development. As we all know that the moment you talk of solar cells, the first thing that comes to our mind is silicon as a semiconductor. But now things are changing. Newer materials are being introduced, which have better potential in many aspects, whether in terms of the availability and the cost or efficiency. Therefore, this area is also going to be very, very interesting and exciting in the coming years. For example, you take paints. There has been a revolution, okay, in the area of paints. Okay, all this revolution was possible with the introduction of these, additives, which are added to the traditional paints. Similarly, actuators. Example, robotics, electronics, semiconductors, diodes. Chemical industry, as I've been telling, the catalysts. Okay. Example, geolites in hydrocarbon cracking. They all belong to this category of material. Now, what are the advantages of nanomaterials? Why we are so much concerned about, studying about nanomaterials or understanding about nanomaterials or to do research in nanomaterials? What is the reason? There must be some sound reason. So obviously the advantages. Okay. So advantages are many. Okay. For example, one of the main advantages of nanomaterials is the size of the particle. Okay. And that could be tailor-made. We have the ability to control the size of the particle. Okay, why the particle size is so important? We will see some of the properties as we move on. As the size of the particle changes, the properties of the material will drastically change. We could never imagine in the normal context. For example, a gold particle, a gold metal under normal circumstances appears yellow to all of us. But as you cut down its size, narrow the particle size to lower and lower. When it reaches the size of a nanometer, its color is going to be entirely changed. Not only color, the properties associated with will be changed drastically. Another advantage of nanomaterial is the porosity. such materials do possess. Therefore, they can be of use. Similarly, generating energy, that is, we want alternative sources of energy, which is more efficient, cost effective, and from readily available raw materials. That is our objective. So, therefore, in that area as well, nanomaterials are going to play a major role. Already, some of the technologies are already out in the market, but still, much bigger challenges. Right? We can do, you know, cap more and more in this area of this nanomaterials. Applications in electronics and computing industry, we are witnessing over the last few decades. In the 1960s, 70s, the size of a computer used to be very high, and today, computer size, I don't have to tell, we have the computer in our hand in terms of a cell phone. How this would occur? It's all because of the evolution of the materials which are involved in this particular industry. Okay, the technology evolution and revolution in the technology. Similarly, there is another advantage of nanomaterials. The surface to volume ratio of nanomaterials is particularly useful in the medical field. That permits bonding of cells and active ingredients. And the result is increase in the likelihood of successful ways of dealing with the disease control. This is another advantage. But we have to look at the disadvantages. If you talk to me, I would focus more on the disadvantages of any new technology first. It has to be addressed properly. So likewise, in the area of nanotechnology also, when we are using nanomaterials for different applications, we do come across some disadvantages of handling such materials. That could affect the health, as mentioned there. Safety aspects of exposure to such materials can cause damage to the human. I'm talking about the advantage of nanomaterials, keeping in view of today's context. We are all running through the pandemic. But the technology that someone was developing, they could not address the disadvantage of such technology properly. That's why we are all, witnessing the disadvantage, and we are experiencing the disadvantage. The societies are experiencing the disadvantage. That's why I think, as good academicians, researchers, I think we should focus and address the disadvantages involved in any new technology that we are interested to develop first. Okay. Currently, inhalation of nanomaterials, for example, particularly carbon-based nanotubes, nanofibers, they can cause, and they can be detrimental, for human health. They can cause pulmonary effects or, fibrosis, etc. Further possible risks are also there in the ingestion of such materials or dust explosion when it is present in that moment. So all these things I would say that we have to keep in mind before we take up any research or any academic pursuit in this area of research. I start with the carbon structures, carbon-based nanomaterials. Okay. Carbon means the moment we say carbon, the immediate thing that comes to our mind is graphite. Second one, diamond, which are allotropes. And there is a third material which is added to this list called Buckminster fullerene. It is a football-like having football-like structure, consisting of several aromatic hydrocarbons, aromatic rings, which are arranged in a spherical shape. Okay. And this was invented in the early 90s or late 80s, to be more precise. So now we all know very well about graphite. Graphite is having a planar structure, two-dimensional structure. like having several layers of these sheets stacked one over another, and there is a gap between the two respective layers, and its nature is black, opaque, lustrous, slippery, and it can conduct electricity. Whereas the diamond, which is having a three-dimensional structure, it's colorless, clear, lustrous, having high melting point, and does not conduct electricity. Okay. So that is the nature of diamond. So if it does not conduct electricity, it is of limited use to us in the present context. The next material is of utmost importance to us in today's topic, Buckminster fullerene. This fullerene, it was named as fullerene. Okay, it was, as I said, late 80s, and for which Nobel Prize was given in the year 1991. And this discovery was an extraordinary discovery. And it was isolated from one of the very common sources. In our traditional homes, a kitchen used to have that soot which is deposited on the roofs. Okay, and that soot, when it is collected and when it is extracted, okay, the substance that comes out is fullerene. Okay, that means due to excessive, burning of coal, we get that what you call, soot, which is slowly getting deposited over a period of time on the surface of the roof. Now of course we are not we are using LPG, and we don't experience that, but still villages I think we could see in some places. Okay, so that was the source of these fullerenes. So we say it is a natural source. And Buckminster fullerene, it's also called as a buckyball, and it contains 60 carbons, black solid. Okay, and it changes its color when it is dissolved in petrol. Okay, it gives a red solution, and it has free moving electrons, so conduct electricity. Why free moving electrons? Because it is having aromatic rings. Aromatic means there are pi electrons, free electrons. They are loosely bound, therefore they can be made use of in terms of the conductivity. So they are spheres. So CC fullerene are spheres of only carbon, are also electrodes of carbon. Now we say that. Now the next question, when we are telling our students that how many electrodes of carbon we could actually perform, that is nothing but fullerene. So far, in our traditional teaching, okay, that how many electrodes of carbon, we always say to the student, only graphite and diamond. Now we could comfortably add fullerene as a third electrode of carbon. Okay. Next, what are the intended uses of fullerenes at the point of time when it was invented, and when its structure was well studied by several scientists across the world, that they can cage other molecules? How could they guess? Because of the structure of this C60 fullerene, which is large in size, having a large, free space inside the sphere, they were under the impression that the cavity could be used to pump in some elements such as iron, gold, individual elements, or even small molecules. Or we could also add certain molecules to this substance. This was the thought, and unfortunately, most of them have been proven to be correct. In the future, so therefore, it could be extended. In some cases, it is already to deliver drugs in small amounts for slow release. Very, very important. Okay. For example, cancer treatment. Okay. And these fullerenes could be of great help in the coming years. So, next one. What are nanotubes? So, now coming to another type of these nanomaterials based on carbon. Now we have talked about the fullerene, which is based on carbon. There are another type of materials made of carbon, nanotubes. They, some of the carbon materials, they could form tube-like structure. We were talking about graphite. So graphite, we are only talking in terms of the open sheet. That open sheet, just imagine, that is like a mat. If it is gold, okay, we could get a cylindrical structure. That could be termed as nanotube. Now, it is developed for use in computer technology, and it's having a diameter of about 2 nanometers and lengthwise 100 millimeters. Okay. Now, so therefore, two materials we have in hand: nanotubes and fullerenes. Now, what type of materials could be made using these two type of materials are shown here. Here, you could say by taking the nanotubes, we could make, for example, uh, a material like this, a cylindrical structure. Okay, it's a inverse. There's a lot of space inside. That space would be just enough for a DNA molecule which is present in the human body. It could be inserted inside the tube. That means we are engineering a mechanism in which the DNA molecules are inserted into this carbon nanotube. Okay, what for? Okay, we'll see in various applications. So similarly, we could make several derivatives. Now we know the basic structure of fullerene, and we also understood its structure. It consists of loosely bound electrons in the form of pi bonds. Okay, those electrons are freely available to us. Therefore, one can subject that double bond to a particular chemical reaction and introduce a kind of a side, chain. Now, you could ask why? What is the interest? Yes, that we will see. Okay, there are going to be a lot of applications for this technology. Why? Because now we have at our will can introduce groups which are wanted for our applications, which are needed for our applications, depending on the type of application. If you are talking of a semiconductor, you introduce certain type of side chains. If you are talking of drug delivery, we use a certain type of functional groups like a hydroxy here, which can be hooked onto the drug molecule, and therefore we are going to use this fullerene to carry the drug to a particular site. So similarly, you want to make a molecule of this kind, a more robust molecule, we can derivatize it, which could be comfortably used in the technologies such as organic solar cell technology. People have been doing it. There is a lot of research going on in these areas. Okay, so when we talk of the applications of genes, okay, all these applications are intended to improve the quality of human life and to provide new approaches to the diagnostic tools that we are using so far. We want to replace the existing diagnostic tools and therapies which we are forced to use it in spite of their side effects. Now, with the introduction of this technology, those side effects could be either minimized or completely avoided. I will show you some example where a side effect of a chemotherapy is completely avoided when we use a fullerene-based material. Okay, so there are several research groups across the world working on this, and they applications are being available in different scientific journals. Okay. And you see now nano robots become a buzzword in today's advanced research topics, and this is going to play a major role in the human health system. Okay, so it is going to be designed, which is going to act as a machine to cure the health disorders inside the body. Okay. And you see, they replicate themselves, modify themselves, cross to the specific problem to be solved. That means, in short, we can say target specific. Target specific means where the problem is lying, right? We go to that point, just solve it. Okay. Like a machine. Okay. When a machine is damaged, we just take out for a repair. Just the part which is not functioning properly is replaced with a new one. Exactly like human system also treated as a machine. Okay. And that is made possible with the invention of these technologies. Increasing funding or initiatives, of course, it's a fallout of the research. Therefore, a lot of funding is made available for this. So, application of nanochemistry, more particularly, if I have to talk about this discipline, involves both new materials, new principles, and which are going to be used or intended to be used as powerful tools for an extremely effective action against a range of you know diseases when we are talking about curing diseases. Based on what physico-chemical phenomena of the surface plasmon resonance, for example, used to develop technology for drug discovery, antibody screening, ligand fishing, and terrorists. There are different types of nanotubes. We just I don't want to go into the details. There are different types of nanotubes which are known, which are being made, like they're called FIS, and they some of them straight nanotubes. They only conduct electricity in specific conditions. What are the basic properties of nanotubes? Hexagons curled into a tube shape, very strong, conducts electricity, small with a large surface area, can be separated from liquid products for reuse. That's one of the very, very important things. Reuse, recycle, okay, eco-friendly. These are the things that are present with these materials. That uses reinforced graphite, one of the best examples in finished that's already in place. Semiconductors, electronic circuits in modern computers and electric circuits. Industrial catalysts. This is a very, very important area. Industrial catalysts. We have to one day or the other have to replace as many as possible the traditionally used catalysts or traditionally used chemical reagents, which are toxic, either toxic or could be potentially harmful or maybe sometimes explosive. Okay. Particularly, we see nowadays that there are so many incidents happening in pharmaceutical sector industries. Okay, explosions. Okay, one of the reasons is the type of materials that we are using in different chemical processes involve materials which are hazardous in nature, maybe toxic, but we are forced to use them because we don't have alternative at present. But in future, as many as possible, we need to replace with catalysts such as nanocatalysts. Here, I'm showing a work which I was very much involved some time ago, and the title is dodecahedrine and bisbromododecahedrine. Dodecahedrine means, I will tell simply, it's a
Sir, excuse me, sir.
Yes,
Excuse,
yes, sir.
excuse,
Yes, sir. Yes, sir.
sir, your voice is slightly breaking, sir. It is not continuous.
Okay. Thank you
Yes,
very much.
sir.
Thank
Yes.
you very much for that.
Thank you, sir. Thank you.
So, is it okay now? Can you please tell me? Is
Okay,
it okay
okay,
now?
sir. Okay, sir. Okay, sir. Thank you, sir. Thank you.
Yeah. Thank you once again for that update. I should be knowing once in a while how my voice is, because it is so silent for me that I am under the assumption that everybody is following perfectly, everything is perfectly all right. And once in a while, such feedback is highly helpful. Okay, now here I am talking about a new material which is known much before your C60 fullerenes. Okay, and here I am showing you a football like molecule. In fact, if you observe football, you will see there are several 5-member rings present on the football. Okay, now imagine each corner is representing one carbon. Now that is nothing but C20H20. That is called dodecahedron. Why dodeca? It is having 20 carbons, C20H20. And this was the work which was done much before the discovery of the C60 fullerenes. I was very fortunate to be associated with that research group where I had to work in this area for quite some time. And this work has given insights into the invention of the C60 fullerene work. In other words, it has laid the foundation for the researchers in the area of carbon, nanotubes, C60 fullerenes, etc. This was first synthesized in the laboratory. It is not for your information. This is not available from nature. This was entirely to be developed in the laboratory. It took several years, which involved a number of researchers to develop a viable synthetic route in the laboratory to synthesize this dodecahedron. Okay, all this synthesis was developed. Okay, and in fact, I was very much involved in making another new material, which is slightly different from this, where there are 2 carbons which are added inside the sphere. Okay, and this is a work which was planned for 2 years. I'm just putting it in one small presentation. Okay, I do not want to go into the details how it is planned, how it was synthesized, and all that. But the crux of the matter is that the purpose of making these molecules was to study the electronic behavior of these molecules. For example, we introduced easily available double bonds, easily modifiable double bonds in this system. We can create some electron source, and those electrons can be made to conduct electricity. That is the purpose behind this research. So this was published at that time in the journal Anglo. The principal the other. Further, to conclude about carbon, based nanomaterials such as dodecahedrons, and carbon nanotubes, nanoparts. So we have understood the basic concepts involved in the area of nanotubes, nanorods, nanoclusters, okay, and their eventual applications. Okay, and brief mention about the organic solar cells derived from this type of materials. We will be witnessing in the following slides. Now, just let me also introduce you to the term molecular machines and molecular switches. Now, during almost the similar time, so there were researchers going on parallelly. One is dodecahedron, C20H20 hydrocarbon research. On the other side, fullerene research. On the other side, okay, at the same time, several other research groups were making efforts to make new materials, okay, consisting of macromolecules. Okay, these molecules were named as molecular and molecular switches. Okay, why they are named like that, we will see in the next few slides. So now, if you look at this structure carefully, okay, there are 2 rings, okay, 2 cyclic structures which are embedded in one another. That means if you imagine a chain, okay, a key chain or chain in which 2 hooks are there, right? One ring is inserted into the other ring. Okay, exactly like this was done in terms of the molecular machine. Okay, now this size of these molecular machines is in the order of nanometers. Okay, so that is what we are interested in. Now, obviously, one question that arises to human mind is that, okay, this writing those structures on paper is okay, but how do you synthesize in a laboratory? Are they available from nature? Some of them may be available, like porphyrines from the tree plants, but not all of them are available. Okay, so therefore, you have to come up with an appropriate method of preparation. For that purpose, here it is shown. We took the cyclic structure, which is prepared by itself by a different wood, and the other structure we have taken it in its open form. Okay, and now when you perform the chemical reaction under suitable conditions, what happens? This linear structure will enter into the cavity of the cyclic structure. Therefore, we are going to get a new material in which a straight chain chemical structure present. Around that, a cyclic structure is present. That means, in other words, the following, the second structure can give you some idea what I mean by cyclic structure. It looks like a ring. Now, imagine a ring is inserted into a straight chain, like a rod. What happens? Okay, it is going to form a shape like a rod and a cyclic ring. That means we'll see in the next slide. Okay. Now, this is the general representation of a molecular machine and molecular schedule. It's called molecular schedule. Why? Because, okay, before going further, just the straight chain chemical structure is termed as the axle, okay, which is helping the ring to be present around it. A ring is also is around this axle. Now, what is the purpose behind it? The purpose behind it is that we intend this ring to make a movement across the axle. Okay. So by suitable application of appropriate what you call applied, okay, signal. So just for normal understanding, I said signal. Okay. When you apply signal 1, this ring starts moving and moving to the other side, other end of the axle. It reaches the other place. And now we cannot allow it to stay there. It has to be brought back to its original state. Okay. Like in the case of a normal switches, electric switches. If you just imagine electric switch, when you switch on the light, it comes to the other one side. When you switch off, it goes to the other side. Exactly similar principle is applied here. When you apply second signal, it goes back and occupies its original state. This is the intention behind making this type of molecules. Now you look at, there are of molecules which have been synthesized ever since the discovery of molecular sheets and molecular switches. For first point by one extruder. Okay. Here in this particular example, you see the linear structure consisting of biphenyls, and it is linked with the oxygens. One side is sterile group is introduced. Sorry. Okay, and you have a cyclic structure. Now there are two regions. One region is shaded with green, colored with green. Other region is colored with red. Now, by a very simple process, by giving electron, okay, this ring shifts to the green side. By removing electron, okay, it goes back to the red side. That means, what do you understand by giving electron and removing electron? All of us know very well about this concept, oxidation and reduction. Very simple concept. Okay, the very simple concept applied in very effective manner, in which we are able to make the ring move from one side to the other. In the process, okay, it is going to perform certain function. It could be in the human body. Okay, so this was a very interesting paper which appeared in Anglo Technology in the year 2000. The title is Artificial Molecular Machines. This is the beginning, we could say, okay, of molecular machines. And further, okay, it escalated the interest in this area Okay, by many more publications of this kind. Solid state electronically reconfigurable switch. Now, further, we introduce one ring into the other ring. Okay. For example, we have two rings here. Earlier, we have a straight chain, like an axial we call, and we have ring-like structure. So we are able to make the ring move across the axis. Now, what we are doing here, we are taking things, inserting one ring into the other, like a chain. Now, in this system as well, by applying suitable, simple chemical process called oxidation and reduction, we are able to green part, okay, inside the cavity, outside the cavity, as per our design. Okay. So now this type of materials could be of great use both in the electronic industry and also drug discovery field. Medicine. Okay, this is the mechanism. Mechanism how the cyclic structure keeps on moving, around the other cyclic structure. Okay, this is the mechanism. Okay, uh, by oxidation and reduction. Now, this was the breakthrough paper which appeared in Science, okay, in the year 2001. Molecules get why I love this topic. In year 2001, scientists assembled molecules into basic circuits, raising hopes for a new world of nanoelectrons. So this was a paper which has revolutionized the field of research. Okay. Of course, there are much more interesting papers and here later on, which now so far we talked about simple chemical processes, okay, like oxidation reduction. Now, another simple process that could be applied in this context is light energy. By the application of suitable light energy, like for example, fluorescence signal, okay, you could make this happen. That is what the intention is. For that purpose, we need to make appropriate materials. Okay, not all one material cannot be responding to same oxidation reduction. So depending on the type of external agent we are intending to use, you have to change your host system or the chemical substance or molecular machine. So appropriately in this case, this cyclic structure is mixed with the diazo. All very much aware. We have studied diazo compounds, dyes, which impart different colors to the fabric or natural food stuff. Okay, consists of these diazo functional group. They are to a great extent eco-friendly, but natural dyes, synthetic dyes. So that concept is used very effectively here to make diazo compound in a straight chain, and that is treated treated with the cyclic structure, and to the mixture they have applied light, and light of different wavelengths. When we apply 365 nanometers, okay, now this strands, you all of us are aware of, I think so, that cis and trans, we might have studied long time. Cis and trans, that means the in the space they are oriented. Okay, that is what is indicated by cis and trans. Now, when you take the trans, which is more stable, obviously, under normal room temperature conditions, always the molecules tend to be staying in the lowest energy possible state. That is why trans system is always preferred under normal conditions. However, when we apply some energy in the form of light, which could go into the cis, which is high energy system. In this process, there is another reaction that could take place between this to provide a new material in which this cis was inserted into the cavity of the cyclic structure and projecting two outlets. Oh, so which would be joined together to form another ring. Of course, the transformation was not complete. It is reversible. And in another route, the trans directly goes inside the cyclic structure. and it is reversible. That is what should be appreciated in this case. When you apply some light of different wavelength, it goes back to its original state. That is what essentially we require, in the case of molecular machines and molecular switches. That is the key concept. Okay, we should be able to regain the original state without disturbing the material, and the material should be stable. Okay, that cannot be unstable. The materials we choose to make such to manufacture such devices, they should be robust. That is why these aromatic systems are preferred. Now, so far we have learned about the application of oxidation reduction principle and also external light in the form of fluorescent light in order to bring about this, the movement of this, rings from one place to another. Now, the third external stimulant we say is acid base. We all know acid base. Acid base is the fundamental concept and very simple, easy concept, and that is applied in this context. Okay, in this type of materials, okay, we have two regions, okay, of shown with the different functional groups. When we use a base, diisopropyl ethylamine is a base. For the matter, any compound or any reagent or any chemical substance consisting of nitrogen alkyl is treated as base, like ammonia. Ammonia is NH3, and if you replace hydrogens with the alkyl group, it is going to be basic only. So now such material is used as reagent here, and what happens? There is going to be a change or shift of the ring from one side to the other. Now, in order to bring the ring back to its original state, we use trifluoroacetic acid, which is an acid. It's a mild acid. It is a strong acid. Of course, it is more stronger than normal acetic acid. What is acetic acid? COH, which is very less acidic when compared to hydrochloric acid, sulfuric acid, or nitric acid. But we use acetic acid, which is mild. Okay. Now, when compared to acetic acid, trifluoroacetic acid is somewhat more stronger. Okay. But definitely it is much less stronger than normal hydrochloric acid or nitric acid or sulfuric. What is the reason behind using this acid? Is because we need to use only weak acid or weak base. Why? Because we have so many other functional groups in these materials, they should not get affected by the reagents. Okay, to make the system robust. So we cannot expose such materials to very harsh conditions, either in terms of temperature or exposure to reagents. So what is the conclusion from these molecular machines and molecular switches so far? That we have been able to understand what molecular machines are and what molecular switches are. Molecular machines are essentially the chemical substances which are designed only for particular intended applications, consisting of robust architecture. Okay, they should be stable to different conditions. Why? Because ultimately, when you are planning the application of molecular machines, they will be exposed to different conditions. Under those conditions, they should be stable. Okay, so while designing the synthesis itself, we should be careful. Okay, we should use appropriate method in order to make the molecular machine very robust and stable to all kinds of environment. At the same time, you should act as switch. Switch, as I told before, switch is like a normal switch. Switch on the fan, switch off the fan. Switch on the light, switch off the light. How the switch is functioning. So is this molecular machine, this compound, this chemical substance should listen to us. We as human beings should be able to have control on the operation of this molecular machine from outside. Then only we can operate it. Either it is inside the human body or in an electronic, environment. Okay. So that we should have the whole ultimately. That is the purpose behind it. Now, in this process, we cannot afford to use very costly, okay, very toxic or explosive or unwanted, chemical processes. We have to choose the processes which are affordable, which are not only affordable, which which keep the molecular machine safe, which does not decompose or destroy molecular machine, or the it should not destroy environment in which it is present. Okay, let it be human being or any normal electronic application. That's why radiation reduction, acid base, light energy. Okay, so they are used. Okay. So that is another you know milestone of discovery in this area of research. And it is on, research is going on. You see, even today also you see Journal of American Chemical Society, Nature, Science, you across a number of articles in this area. Okay. What is the intention? If there is no application, nobody is interested to fund or nobody is interested to work on this area. Okay. Obvious reason, there is the tremendous scope for the application. That's why again these materials are being explored. Now we move on to the medicine part. Nanomedicine. Medicine we know. Traditionally we consume medicine for treating various disorders. Okay. And traditional medicine, how it is used. Okay. A particular disorder happened, immediately it will be asked to take a particular medicine. Just consume the medicine. That particular medicine is going to be helpful. That's okay. That's a different part. But at the same time, it is going to get distributed to every part of the body, whether it is wanted or not wanted. So therefore, in such situation, the human body is exposed to undesirable quantities of unwanted materials, which is not at all desirable. So that is the reason why most of the medicines was damage to the human body. Okay, so therefore, nano medicine is going to play a significant role in this area of research. Okay, nanotechnology it provides wide range of methods and solutions that optimize drug delivery in pharmaceutical products, which is one of the key aspects of drug delivery. Limited drug or developing a drug, discovering a drug is one part of the drug discovery. But at the same time, how to transport this drug safely to the target is called drug delivery. That is equally or more important, okay, in the pharmaceutical industry. Okay, so that is another one. And in the process, what is that we are going? Why we are interested in the nanomedicine? The potential reasons are the current treatments by following the traditional method of inserting the drugs into the human system, causing to treat chemotherapy like disorders, okay, or treatments. Sorry, treatments. Okay, in the process, the normal the part of the body is also getting affected. Therefore, such a thing should be minimized or should be avoided. In which nanomedicine will play a major role. Okay, and already in this context, many scientists, academicians at Harvard and MIT, they have been able to attach, for example, RNA and DNA and RNA, which measure in the order of 10 nanometers in diameter and considered to be nanoparticles, and filling them with a chemotherapy. Okay, and these strands, RNA strands, then attracted to cancer cells. Okay, then the nanoparticle, once it encounters the cancer cell, it is going to attach to itself, okay, to the cell or adheres. If we use the correct word, adhere, okay, and releases the drug to the cell. The drug by itself may not easily penetrate through a cell, affected cell. So there, this RNA, okay, is going to be helpful. Okay, that is how the drug is delivered to the particular target site. This directed method has great potential, okay, in the patients who are being treated for chemotherapy. That it is going to avoid all the negative effects. that would be improper drug delivery or side effects. And there is another thing which is, as I've been talking about, molecular machines. Okay, so now here the scientists are treating the whole human body as a mission, like a normal mission, right? And when there is a defect in the mission, what we do, we just go and open up the mission and just find out where the problem is, okay, by using different tools and rectify it or replace that particular part with a new one, and then again just bring it back to the normal. The similar principle is applied here also, where is also a kind of engineering. Okay, it's a traditional engineering. It is a modern, in which in this advanced technology, medicine must catch up with the technology level of human body before it becomes really effective. Okay, if the human body is basically an extremely complex system of interacting molecules, the required technology should be fully understood and repair the body. Okay, the consequence of this level of technology would be the ability to analyze and repair the human body as completely and effectively. That's very important. As completely and effectively as we can repair any conventional machine today. This is the great statement given by Brian Hope in cell repair technology. There is another example, nanorobotics. There are so many names given to this: nanorobots, nanoids, nanites, nanomachines, or nanomites. It's an emerging technology, creating machines or robots whose components are, close to the, scale of nanometer. More specifically, they refer to the nanotechnology engineering discipline of designing and building nanorobots. Okay, whose size ranging from 0.1 to 10 micrometers, and constructed of nanoscale or molecular components. It's a very interesting field. Now, another very interesting example, how a nanomaterial could be used, or a drug for that matter, could be transported to the site of interest that is called target. Okay. In this case, in this particular example, a bacteria, normally available bacteria, is used effectively to link to the drug which is to be transported, brought to the target site. Okay. So it's a cargo of nanoparticles present. Okay. The drug is hooked onto the bacterium. The drug by itself may not be able to reach the target site. On the other hand, the moment it is hooked to the bacterium, which can easily get the access into the cell membrane and get inside the cell. Okay. So that is what is done here. So bacteria can be used to carry drugs, DNA, or sensors attached to nanoparticles into cells for treatment, gene therapy, or diagnosis. Okay. So there are different fields. One is diagnosis, is one identification, and then therapy is another part. Sensor is one just to find out sensor. Okay, it would sense. Okay, so for this purpose, the drugs are hooked onto the bacteria, and which are in turn going to carry these drugs towards the cell membrane. The
Dear participants, please wait. Seems some network problem. Professor sir, we can't hear your voice, sir. Because of some network issue, our resource person has left. He will join within 2 minutes. I request all the participants, please wait just 5 minutes. We are contacting our resource person to get a resource person to recontact again.
I'm very sorry for that. I could, yeah. Just like to share because now. I hope see now. I hope you can see now. Can
Yes,
you please
sir.
tell me?
Yes, sir. Yes, sir. But
Yeah, I have switched on. I switched off the fan. Yeah.
Okay. Sir, it seems that if you are switching your video, we can avoid some more network trafficking, sir. We can hear your voice very clear, sir.
Okay. So I have what I should do? I have to switch off
Your
the
video, sir.
video. Okay, fine.
Yes. So that we can avoid some network trafficking, sir. Yes.
Right. Okay, right. Yeah.
Sir, yes, sir. Your presentation is visible, sir. Please continue, sir.
Yeah. I think we have completed this molecular schedules up to the
Yes, sir.
earlier.
It is over, sir. Over, sir. Yes.
This is also over.
Actually,
This,
now
up to
we
here,
are in
yeah.
bacteria can be used to carry drugs. In that portion, we are.
Okay. So,
Yes.
yes, nanomedicine. They are in
Yes, sir. Nanomedicine. Yes,
contact.
yes.
Nanomedicine. Right. So, nanorobotics. Right. Let's start from here. Nanorobotics. So, there are different names given to this: nanorobots, nanoids, nanites, etc., nanomites, etc. It's a wonderful technology which is currently being developed. Okay. Now we go to the use of bacteria, for example, as carriers of drugs. So the drugs usually they may be effective to cure particular disorder, but the thing is they themselves may not be able to penetrate into the cell, which is the target. Okay. So in, in order to make the drug to reach the target site, we take the help of bacterium and hook it to the drug, and bacterium can access to the cell. Okay, why? Because there's a good communication between the cell affected the cell and the bacteria, and in the process, it is gaining access into the cell, and in that process, it is also going to carry the drug inside the cell. Once the drug enters into the cell, and it is going to do its job. So, for this purpose, okay, this method is being adopted. In this process, okay, DNA or sensors attached to nanoparticles into cells for treatment. Gene therapy takes place, and the gene diagnosis takes place. So first diagnosis and then therapy. Okay, all these things could be done using this technology. Okay. Similarly, we are all aware of antibiotics. We use antibiotics for anything and every health disorder very frequently. And we also know that antibiotics have the property of getting resistant. A person who is continuously exposed to antibiotics, after some time, it is going to create the resistance to the human body. And therefore, such patient, if he is exposed to, if he is given antibiotic again, same antibiotic may not working again. In such cases, you could replace with the nanotubes and based drugs. Okay, yeah. Okay, nanotube drugs made from chemicals called amino acids can puncture bacteria cell membranes, killing them. The molecules are ring shaped. About okay, so they usually they get into the system, and therefore it is a good replacement for antibiotics. In the drug delivery process, okay, our nanomaterials can be transported, okay, very selectively to the desired site, which is we call it target specific. Okay, and it is target based drug dose. What is the outcome here? Is that we are able to decrease the quantity of drug that is needed. Okay, that means we are going to decrease the quantity that is required to lower doses. Ultimately, it is going to reduce the side effects. Okay, that is what we are interested in. Okay, so for example, sometimes the body has to use stronger drugs. Okay, stronger drugs. In such cases, how to do. Suppose if the patient is exposed to stronger drug, it may be useful to cure the disease, but other organs could drastically get affected by these stronger drugs, which we don't want to happen. In such cases, okay, nanoparticle, nano carriers, okay, can be of great help. Can take these drugs, stronger drugs, what I mean to say, to the target of interest and treat it very specifically. So that means we are able to avoid a lot of side effects. So use of particles in cancer killing is an example of target specific. Gold plated spheres. Gold is the best example. Okay. We will see one video. I have an interesting video I would like to share towards the end of this talk. Okay, based on gold. Gold plated spheres will link tumor cells. Okay, the nanoshells will be heated from outside, okay, with infrared source. Heating the shells will destroy the cancer cells, leaving the surrounding tissue unharmed. Okay, that means absolutely no. Okay. So another aspect of drug delivery. Okay, of course, here this mechanism is more detailed. In improved imaging and diagnostics. Okay, with better contrast agents may help the diagnose the diseases more sensitively. There also we can use nanomaterials. For example, enable the detection of very small tumors, other organisms, which causes the disease over a period of time. So those things can be detected at an early stage. Okay. Very simple. We are all having dental problems, right? In the dental treatment, teeth cleaning robots collect harmful bacteria uh, in the mouth. So this is another application of nanotechnology. Lungs, lungs are most essential part of the human body, which is very much needed in the today's context of exposure to corona and this pandemic. The lungs are the most targeted site. Okay, that has to be protected, and that in nanomaterials provide materials, drugs which could clean up the lungs. Okay, cleaning robots can be used. We have natural macrophages in alluvial. They are not able to metabolize. So that some of the substances like consume asbestos. Okay, silicon, for example, if we consume, it cannot be metabolized in the body. Okay, there are so many foreign particles our human body cannot digest. Okay, such cases, this type of those things can be removed by using this technology. It is nanotechnology is going to find great use in the cleaning of artery, which is related to nerves connected to heart. Okay, extra fat can be removed from the arteries with the cleaning robots, mobile nanorobotic, janitors they call. Okay, which are green in color soon. Okay, so they patrol the lungs. Okay, and collecting inhaled debris and transporting it to recycling stations. Okay, blue. It is shown blue. Okay, that means nanotechnology is going to be, of great use in the, maintaining the human in more effective manner than what is possible until now. What are the conclusions from these, two examples? Nanotechnology finds an extensive use in treating various health disorders, which are not, met or not treated properly by the traditional way of injecting drugs. And in this process, we are going to minimize either minimize or most of the time completely avoid the side effect. Okay. This is a great advantage. Okay. Now, that was as far as molecular machine, nanomedicine is concerned. So far we have completed three things like carbon-based nanomaterials, molecular machines and molecular switches, and some part of nano. Okay. And now the other thing is organic solar cell technology. Okay. And I know that I'm just giving this presentation to learned audience who are already aware of this one, who are already doing, must be doing some research on this. Okay. Here, just I want to just recap what is happening in this area. Here, what are the advantages of organic solar cells? Disadvantages. Okay. What are the advantages over the silicon-based, semiconductors? Organic cells, they are light in weight, semi-transparent, environment friendly, cost effective. They can be manufactured to any scale. We know the quality and how much you can manufacture. Okay. Of course, there are some other concerns. That's a different thing. It results in huge savings. Okay, and they are going to be found cheaper. It is flexible to use PV modules, easy to integrate in a simple, right? What are the potential disadvantages? Anyway, polymers have got their own disadvantages. But main disadvantage in this context is efficiency, the power conversion efficiency. That's why silicon is obviously superior with over 15% conversion of solar light. But organic solar cells, okay, as on date, of course, now I think it is improved. When they were first discovered, they were in the order of 1%, 2%, 3%, slowly improved to 5%. Now there are organic solar cells which are as efficient as 10%. Okay, whose efficiency is about 10%, or sometimes even beyond. There are some materials. Okay, and these solar cells are expensive. So this is potential disadvantage in terms of efficiency compared to standard silicon-based semiconductors. Its lifetime is less. Organic solar cell, being organic in nature, usually inorganic compounds are more stable, having high melting points or high resistance, high stability towards moisture, etc. Whereas organic substances are not so stable. Okay. When they are exposed to light or moisture or any other atmospheric substances, they tend to get decomposed or destroyed for a period of time. So that risk is always there. Okay. Apart from that, okay, that can be addressed. Okay. So organic solar cells therefore have potential, uh, applications. Here are the recent developments in this area, where here in this particular example, polythiophene polymers are investigated. Okay, here with high efficiency. Okay, over the traditional 3%, 2%, etc. So in this process, okay, they have used a mixture of the solar cell, organic solar cell, along with zinc oxide, silver, stacked over another. Okay, and then fabricate the cell and find out its efficacy and its efficiency. It's going to be much higher. Okay. And you see, this is another very interesting example how the carbon, fullerene, P60 fullerene could be used effectively in the fabrication of solar cells. Here, the P60 fullerene is hooked onto a molecule. Okay, several derivatives are prepared here, and their efficiency, power conversion efficiency, are calculated. You can see here the PCE is dramatically improved to 6.43%. Okay, by introducing the C60 fullerene. So that's why these fullerenes are going to be of great interest in the future. Similar example is shown in the next here. In this case, thiophene, polythiophenes, they are used. In this case, see, I am going to focus only on the particular thing, one aspect. Okay, there are so many aspects involved with the materials involved, for synthesis, characterization, planning, design. So many things are there, properties, definition, etc. I'm not focusing. I'm not going to focus on all those aspects. The important point that take-home message from this is that whether in the process of developing this substance, whether power conversion efficiency increased or not compared to the standard. Okay, so in this case, okay, by changing the substance, we are able to achieve in the order of 6%. So likewise, there are several groups which have been working, and they're constantly fighting to improve the PCE, that is consumption conversion. Okay. Now this is another 2012. This this example is again 60 fluorines. Okay. So here also the efficiency is improved to 5.1%. Okay, so that means the C60 fluorine, when it is hooked to different types of roots, and the efficiency is calculated. On an average, it is going to be around 6% as of today, but it could be in the days to come or years to come. But a continuous research is happening in this area. So that is one of the aspects I was trying to focus in today's topic. My interest was only just to let you know that okay, that is the area one actually a researcher could focus on, okay, in the current context. So what are the conclusions from this? Okay, for examples, solar cell technology is the most important. As we are already experiencing, the organic solar cells are being used in today's OLEDs. That's why a revolution in television industry we are experiencing. They are all based on the nanomaterials, organic-based nanomaterials. They provide good efficiency. Okay, so in the organic solar cell technology also, we definitely hope that it is going to bring about a increased efficiency. That's what we are more interested. So with that, we just come out of the solar cells. The last topic of my today's presentation is about some drugs. So we're talking about drugs. A brief exposure. I will not go into the details of this, how they are designed, they are synthesized, they are studied, all those things. But just to say a few words about drugs, okay, how they are derived, okay, in short. Okay. So usually drugs are of two kinds. Drugs which are naturally available. That means the drugs which are derived from nature. Could it be plants? We call it terrestrial source, or from sea source, they are called marine sources. So from either from plants or marine source, drugs can be obtained to a great extent. Around 50 to 70% of the drugs available today are derived either from terrestrial or marine source. Most of them from the terrestrial source, particularly plants. Okay. So, for example, I have shown some of the examples: anti-cancer drugs, Taxol, big plastic. These are all plant-derived, drugs which are being used currently. They are the drugs which are being used currently to treat cancer. So, one such molecule we are all able to make in our laboratory by one of my PhD scholars. It looks very complex, okay, but the method that she has developed is very, very cute, interesting. 3 steps, 3 steps, more precisely, we could get this molecule. Okay, so from the nature, from the plants or marine source, we cannot get large quantities. We have to develop alternative route in a pharmaceutical industry. So where here, this which looks like an actual product, but this was made in the laboratory. Okay, now, this is the brief about the drugs and their source. Now, as I mentioned in the beginning of this talk, in the coming days, those who are, working in pharmaceutical industry to develop drugs and drug processes, they should look for nanomaterials, okay, as reagents in their chemical process. What is the reason? The reason is that in order to avoid undesired explosions, okay, toxic behavior of the reagents, okay, which are uh, frequently being experienced by different people. So we are not new to this. Okay. So in that context, we thought zinc oxide nanoparticles could be a good starting point for our research. One of my research scholars were working, and zinc oxide, it is readily available nanoparticle, and zinc oxide by itself is biocompatible. It's very much required by the human body. Even today, during this pandemic, we are advised to take tablets, which is having nothing but zinc sulfate. Okay, that means zinc is required by the body. So therefore, use of such reagent is not going to harm the human body, and we are not going to use it in the human body. We are going to use it in a chemical reaction. Okay, and the zinc oxide by itself is not explosive. It's easy to handle, white powder, and it can be easily made. It is very cost effective. Okay, so in that context, we have made this zinc oxide. There are different methods available in the literature to prepare zinc oxide nanoparticles, and these nanoparticles were prepared in the laboratory by one of the two methods I'm going to mention. In the first method, zinc sulfate is treated with sodium hydroxide. We get zinc hydroxide, and that in turn is subjected to some kind of mixing, and then a white product is and dried at high temperature to get a white nanopore. Okay, that is nothing but zinc oxide nanopore. And the one that are shown left side is other forms of zinc oxide which are naturally available. Okay, so here the white powder is of zinc oxide is a nanoparticle. How do we know? We will come to it. There's another process also known for the preparation of these zinc oxide nanoparticles, which are prepared from zinc treatment with sodium hydroxide, followed by similar heating and then isolating the zinc oxide nanoparticles. And these are subjected to SEM, as we know that scanning electron microscope and transmission electron microscope to study its structure and to confirm its structure. Did we really get nano oxide or not? And that is in fact proven to be correct. And then once we confirm the structure of zinc oxide as nanoparticle. We have subjected to one of the chemical reactions which we wanted to, you know, use in the development of the drug-like molecule. So our interest is to make drug-like molecule. Okay, and in that process, we have for the first time used as a catalyst, and the results are so impressive in this particular chemical transformation. I am not going into the details. Okay, where we have added B plus C to get the desired product, and that desired product was in fact obtained in high yield. What we mean by yield is that molar ratio. We get uh, high quantity of the product without the side products. That's what I mean to say. So this product was so clean, easy to handle, and easy to separate from the nano zinc oxide, and that zinc oxide can be recycled number of times without losing its activity. So and so there are several advantages of using nano zinc oxide. It's eco-friendly. It can be easily made. It is cost-effective. It is biocompatible. It is not harmful, not toxic, and at the same time, it is doing our desired business. That is desired. It is converting our reactants into products in a very clean manner. This is our observation, and then we have, of course, uh, we cannot say simply that we got a product. The product has to be characterized by using different tools. We have different tools: proton NMR spectroscopy, okay, C13 NMR spectroscopy, mass spectrometry analysis, okay, infrared spectroscopy, ultraviolet spectroscopy, etc. We use all those techniques in order to derive or characterize this compound, in order to prove that it is in fact this compound we are talking about. It is not in any other compound. This is very, very important. Okay, in the drug discovery process, we should know what we are dealing with. Okay, so in fact, when I'm talking about zinc oxide, in fact, in industry, I was there in industry for quite a few years. Okay, uh, one of the very aspects in the academic also is that everyone should be aware of the property of the chemicals we are handling. Okay, that is what is known from molecular safety data, MSDS, which is available freely from internet. So we should know the properties of the materials that we are handling. Then we can avoid all the hazardous explosions, etc. Anyway, coming back to our topic, we have made different molecules. We have characterized with the different spectral data, and then finally we concluded that these are the design. Once we got these compounds, we have subjected to the screen with the help of one of my good friends in University of Hyderabad, okay, Central University, to perform anti-cancer studies, and we found very interestingly these compounds showing good activity. They are proven to be good anti-cancer activity. Of course, they are showing activity that should be increased or whatever modified. That's it. Next level. Okay. Initially, they are showing good promising signs. And we have done number of computational studies, to make sure that our drug is in fact, sitting in the enzyme target. Okay, and it is an engineering, we call it. Okay, and it is giving data. That data is analyzed, and there are several parameters we get. We take several parameters into account and their values. Based on those, we say that this compound is good for this target or not. This is the process involved in drug discovery. And as far as drug discovery is concerned in today's context, I don't have to elaborate because of the pandemic here, COVID-19, everyone throughout the world, has enough knowledge about drug discovery, new drugs, etc. How long it will take to develop a new drug, how long it will take to develop a vaccine. So in order to develop drugs, it will take 15 years, but it is accelerated. We can get it much faster. But these are all the initial trials. Our molecules are showing good antimicrobial activity as well, okay, on different strains. So that is one part of it, using nano zinc oxide. Therefore, we found that nano zinc oxide is extremely useful, okay, in the chemical transformation. That's why I strongly recommend the current people who are looking for technologies in the pharmaceutical industry. They should focus on the use of nano reagents instead of using the routinely or what we call traditionally used reagents in order to avoid the explosions, etc. And with that, I go to another one example. I'm taking a lot of your time, and just about it. I will conclude in next 2 minutes. Okay. The last example is we also have put with a collaboration. We have done some research on a plant. From the plant, we have isolated silver nanoparticles. Okay, and characterize them. Okay, and what is the intention? Why should we do it? Because any nanoparticles from the source could be better than synthetically made. That is the reason. And we were able to make from pomelo fruit citrus maxima. That is the plant name. And from that, we are subjected to several conditions. Finally, we are able to make silver nanoparticles, and the progress of the formation of the silver nanoparticles was carefully monitored. Okay, and it is represented with the signs here. Minus means no change, plus means small change after 30 minutes, 1 hour, and then after 8 hours there is strong color change, and after 24 hours it turned into black. Based on the color change, we say that okay, silver nanoparticles are formed, and therefore we subject to further work. And finally, the material obtained is subjected to SEM analysis, and from the SEM analysis, it is clearly known that silver nanoparticles are spherical in size, and that is right, and further proved by SEM analysis as well. And this say that silver nanoparticles are produced, and they are subjected to various bacterial tests, and they're showing promising actually silver nanoparticles. As you know, silver nanoparticles are going to be the future. They are going to be used extensively in the future in terms of as like antibacterial substances in the fabrics, textile industry. Okay, some such applications. Okay, we are going to find a lot of applications. That's why one of the great interests in the silver nanoparticles. So the essence of this one is in the chemical process, one could use different metal oxide nanoparticles or metal nanoparticles, and they themselves can be of great use. Okay. Okay. So what are the conclusions? We are able to make silver nanoparticles from the plant, and it is characterized, and then there it is investigated. Okay, after characterization. So this is the molecule I was talking about. One of my scholars has made successfully in very short. Okay, in a pharmaceutical industry or any academician, will once you see the structure, it is so complex. It will take years to synthesize in a laboratory, but using a short method, okay, the scholar was able to make these steps very effective. Okay, and we have to pursue this. How best we can make this, project it as a product in the coming days or months. Yes. So with that, I have almost completed all my actually presentation. Then I have few examples which are in the form of videos. I would like to share with you. Just let us all enjoy for a moment. Then just understand how the future is going to be as far as nanomaterials and their applications are concerned, which would be explained like this.
Sir, excuse me, sir.
Hello. Yes.
Sir, we are seeing video, sir, but audio is not coming. Can you explain?
Not visible. 1 minute.
Video visible, sir, but audio is not there.
Yes, sir. Yes, sir.
Sir, Video is visible, sir, but audio is not hearing, sir. So can you explain
Oh,
this better? Dear participants, please wait. Due to network problem, we got some issue.
is it visible, sir? No?
Not yet, sir. Not yet.
Yes.
Sir.
Not yet. Okay. So now I'm going to try to play the video. You said
Okay.
voice is not visible. Okay, we'll try again. If it's
Okay,
still
sir.
not heard, then I will explain.
Okay, sir. Okay, sir.
Now, can you hear now?
Um,
Can you hear?
yes, sir. We can hear your voice only, sir, but not video.
Oh, not there, not there. Oh, okay.
Yes, yes.
So how to?
Sir,
Yes, yes. Okay.
video can if you play video, voice will not come means you need to use external speaker, then voice will come, sir. Otherwise, you play the video in Chrome tab, sir. Share through Chrome tab, that video will be placed.
Okay. Chrome tab. Okay. So, 1 minute.
That video is an online, sir, or you're offline, sir.
It is online. Online.
Then you can share Chrome tab, sir. Chrome tab. Present now there is the option in the present now option, a Chrome tab. That is the best for video animations playing, sir.
Yes. Is it now? Or I have to, if I log into the Chrome itself, that would be right. I think my network is slow, sir. It's very taking longer.
Okay, sir. Okay, sir. Please carry on.
Take, yeah.
Sir, otherwise, our participants are suggesting you can post your YouTube link in our chat box, sir.
Is the
It will be useful for others.
but otherwise the video is visible. That's what you're saying.
Yes, sir. Yes, sir. Yes.
Uh, or I switch off the sound, then I will
Okay,
explain
sir.
sir, what's happening here. Yeah,
Okay,
that would
okay,
be
okay.
better.
Okay, sir.
Oh, that would be better.
Okay.
So basically here, what we are talking about is the gold nanoparticles, how they function, how they work, when they are injected.
Sir, video is not visible, sir.
Video is sharing.
You are presenting, but
Yeah. Is it visible, sir? Now, what I'm doing?
yes, sir. This loading is showing, sir.
Yeah. So, screen. Is it visible now? That nanoparticles. Is it visible?
No, no, sir. Not yet, sir. Yes, sir. It has started, sir. Yes, 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 sir.
It's started.
Yes.
Yes. So the step one is, nanoparticle. What we are talking about is two is nanoparticles. They selectively infiltrate the cancer cells. Affected cells. So once they are inside the cell, what is going to low energy short? Laser processor, on shown on the nanoparticles. They respond and they take up the heat and vaporize the water molecules inside the cell. And because of that vaporization and the pressure develops bubbles. Okay, small bubbles explode. Okay, because of that explosion, cell is exploded. The whatever cancer cell is broken into small pieces, and it is taken out of the tumor system through the process. Okay, so this is 17 times more faster than conventional therapy. Okay, and it kills all cancer cells because of the normal cells. It's a great advantage, and there is no surgery is involved here. Okay, there's no surgery. Okay, surgical procedure is not involved, and including aggressive cancer cells. Okay, that are resistant to radiation. Okay, and this is technology which is going to be the order of the day in the future. That is what this video was talking about. Okay, so then we go to another example. Hopefully that is visible. We have total 4 short videos. If you have patients, we can just hear those videos. One is based on the iron nanoparticles, iron oxide nanoparticles, how it could be used. The second video talks about this is just we can just see the video. How the drug is carried to the affected site by nanoparticle. Okay, that is nanoparticle based drug is is it the voice now still not heard, right? It is not heard. Can you say?
Sir,
Please do the
video also not visible now, sir.
please also not visible. Okay. presentation.
Sir, sorry to disturb you, sir.
Yes, yes, please tell me.
Sir, we can post that YouTube link in chat box, sir. Is it possible, sir?
Yeah, that link.
Yes, sir. YouTube link. We can share in the chat box,
Yeah.
so that it will be useful for our participants also, sir.
Yes, sure, sir. Actually, I can explain, sir, what is present in other videos, sir. That is
Okay.
essentially
Okay.
about
Okay, sir.
iron oxide nanoparticles, for example, how they could be used as a drug. Okay, for example, in treating brain tumors, right? Iron oxide being magnetic by itself, nanoparticles of iron oxide, when they are injected inside the body, and they are transported to the target site, and from the external, source, we give the magnetic field. They break open into small pieces. During the rupture, they are going to break the actually affected cancer cells selectively over the normal cells. So that is one of the videos is showing. Okay. Other video talks about how these nano carriers, the nano carriers or the nano machines, molecular switches. Okay, it is equated with a normal switch. I was talking about that is shown in the form of a video. Okay, that's all about it. These links I will be sharing. Okay, so no problem. I will share. I'm very sorry about it. I wanted to show these videos, but unfortunately, due to some software issue, could not. I beg your pardon for that. Let me try final. If it works, it's okay. Otherwise, let's move on to the next like last slide. I'm trying to share. Okay, let's see the next slide. Okay. Right. Okay. These are the several links. Yeah. To summarize today's presentation, we have covered the basic aspects of nanotechnology and different materials, particularly fullerene-based materials, molecular machines and switches, organic solar cells, zinc oxide nanoparticles, silver nanoparticles. How they could be, explored further. That's what we have, that I was able to, cover. And I hope, I was able to convey some, key points relevant to these materials. And, since I'm one advantage is that I was dealing only with learned audience. Okay, so it is already known to some extent by everyone. So I hope I'm able to refresh more in this, contribute some more. So that way, to summarize, okay, we can do a lot of things with the nanomaterials. What have been achieved so far very, very less than what is in store. There is a lot more that could be, possible from the nano materials and their applications. Right. So, but one thing I would like to focus on always when a technology is being developed or being pursued, we have to look at the side effects. Okay, side effects or or the disadvantages. So we should first address them properly. Then only we should take the technology into the social market. So that is my actually strong feeling. Why? Because many technologies they are coming, but their side effects are not addressed. What we are the entire world and we are experiencing, the whole world is experiencing, is one such thing. Okay, technology is developed, okay, but the side effect is not addressed properly. So I actually, this is my research group. Five have already obtained the pitch. DB Appalnai, Robert. DB was working in an engineering college in Vizag itself. Appalnai is working in industry. Alex Robert is a colleague of mine here in Githam. He's working. Real and Soccer is working in industry. Anand Mohan is a faculty in Srikakulam University, Ambedkar University. And here, Madhavi is pursuing they all others are working correctly. Okay. Yeah. A brief mention about our university, Githam, deemed to be university, located in Visakhapatnam, also has got branches in Hyderabad and Bangalore. Githam was initiated by an eminent industrialist and philanthropist, Dr. M.V.S. He has nurtured this institute right from its inception, from a small institute to an institute of level. And I think everyone of Githam is grateful to him. Unfortunately, he passed away a couple of years ago. So here, this first, this is the entrance. We have TIS means Githam Institute of Science. It's being named as it is named as C.V. Raman Bhavan, and it looks like Parliament. Yeah. And library, the library is well sophisticated, having a lot of online journals and reading available books. Okay. GIT, Githam Institute of Technology, has got so many departments, all branches of engineering. Like here in Vizag, we have apart from Vizag, Hyderabad, and Bangalore, we also have all the branches available there as well. That was about Githam. This is the Githam Medical College, which was started a few years ago, about 5 years ago, and it is monument in terms of its construction. Okay. Finally, acknowledge. I would like to sincerely thank Dr. Chandrasekhar Reddy, head of the Department of Mechanical Engineering, for inviting me to present, on this edition. I am really thankful and grateful to him, and I'm grateful to the Venkateshwara University College of Engineering, for the kind invitation to me as a person. Of course, this entire program is being organized by ATAL, the ACT Training and Learning. It is ATAL, named after I think, actually, but I think this is the initial letters ATAL, derived from ACT Training and Learning Academy. I am grateful to the organization for giving me this opportunity. And yesterday it so happened I could listen to the chairman and vice chairman's speeches in the evening. Good like it was they were very inspiring. You could wait this. I think Vamsi Krishna and the department of the kind always communications in the last 2 days. Actually, when Dr. Chandrasekhar Reddy spoke to me, I was not at all prepared, but then after he spoke to me, immediately I could recall all those things that I was involved, and I tried to bring relevance to the topic. Finally, namaste. Thank you very much. Thank you all for your kind attention. That's it. Actually, this intention of this talk was to pass on the good things to the students, not to the faculty who are already present in this. They are already in the teaching line. They are all colleagues, and I request whatever good thing you have learned about it should be passed on to the students. Actually, students should be motivated in this actually type of work. Okay, nano materials is the future. That's why we have to make the students to you know get motivated by this area of research, and then get new ideas than what is known until today. So with this thing, I would like to conclude. Okay, and thanking you once again. Thank you very much, sir. Thank you very much.
Thank you, sir, for this excellent presentation. Sir, shall we proceed with the question and answer session, sir?
Yes,
Sir, I will read some of the questions are available in our chat box. I will read from reason.
yes, yes, sir.
Uh,
From the
I
chat box.
yes, sir. I request the participants, please unmute yourself. You can ask question to director or resource person, or you can type the question in chat box. We will ask on behalf of you.
That would be better, sir. That would be better.
Sure, 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 sure. I request once again participants, please unmute yourself and you can ask your question. Sir, one question from Professor Sunil Kumar, sir.
Sir,
Which type of nanomaterial is best suited for future medicine applications?
sir, there, there are
Nano.
I request participants to please switch off your videos to avoid network trafficking. Participants, please wait due to some network problem.
Yeah, I'm sorry, I was in mute. So I hope I could answer the question. Zinc oxide, silver oxide, iron oxide, and is iron oxide, zinc oxide, silver oxide, and gold nanoparticles. They are likely to have good potential in the future as medicine. Okay, and zinc
Okay, sir.
oxide is biocompatible. Yeah.
Thank you, sir. Thank you, sir. Sir, shall I proceed with the vote of thanks, sir?
Thank. Yes, sir. Yes, sir. Thank you.
Yes, yes.
Yes, sir. Sure, sir. Yeah, please.
Thank you very much for your excellent presentation, sir. It is really very informative session, sir. You have started with advantages and disadvantages of nanotechnology, nanomaterials, and nanochemistry, nanomaterials in various applications, and nanomaterials and solar technology. Nanomaterial catalyzed chemical reactions like nanomaterials in medicine and in future medical area. And you have started carbon structure, fullerenes, nanotubes, and applications, and molecular shuttles. And it is really vast. And particularly, we are very much interested in nanomedicine and the future of medicine, nanomites, and nanorobotics. Really, it is excellent presentation, sir. Thank you very much, sir. It is a very detailed and informative session, sir. Thank you, sir. Thank you.
Thank you all, sir, for your kind attention. And any suggestions you could get in touch with me by email, sir. Thank you very much, sir. Once again for kind invitation. Yeah. Thank you very much, sir.
Thank you, sir. I request participants, our today morning session is over. Now we will rejoin again around 1:45 p.m. The topic is nanotechnology for materials development and applications from Professor Rajalakshmi G from VIT University, Vellore, Tamil Nadu. I request the participants, feedback link is available in the chat box. You can fill the feedback, it is for our administrative purpose. Once again, I request participants, our morning session is over. So we will join once again around 1:45 p.m. Thank you for all.